today's lesson, where we will be discussing factoring. Specifically, we will be leading up to what is sometimes called the illegal method of factoring. Okay, we'll see here shortly why it's called the illegal method, but there's some preliminary steps before we get there. First of all, a quick review of FOIL. You remember FOIL from high school algebra? The first two terms, outer two, inner two, last two terms, hence the acronym. So, as an example, if I have x minus 2 times x plus 3, okay, my first two terms, x times x, that's going to equal x squared. Outer 2, x times 3 is going to be 3x. Inner 2 is a negative 2 times an x, so I'm going to subtract 2x. And then the last two, negative 2 times 3 is negative 6. Combine like terms, I get x squared. 3x minus 2x is going to be 1x minus 6. Okay, so that's FOIL. Now, if I want to undo the process, that's where factoring comes into play. All right, so that's where I look for factors of negative 6 whose sum is equal to 1. Okay, so that's sometimes done in a table. What do we have? 1, 2, 3, and 6. So 1, 2, 3, 6. So 1 times negative 6, 2 times negative 3, 3 times negative 2, and 6 times negative 1. Those are our 4 possible combinations. 1 minus 6 is negative 5. Negative 5. 2 minus 3 is negative 1. 3 minus 2 is 1. And 6 minus 1 is 5. Okay, so looks like this is going to be our winner. Another way of writing that out, so you can think of the table as the shorthand method. What I'm really expressing is this: x plus 1, x plus 2, x plus 3, and x plus 6. Okay, these are times x minus 6, x minus 3, x minus 2, and x minus 1. All right, so by foiling, I get x squared minus 5x plus, minus 6, okay? In the second case, x squared minus x minus 6. X squared plus x minus 6, and x squared plus 5x minus 6. Okay? Feel free to check me that my foiling was correct. But this is what we're doing. The table is the shorthand method of doing that. Now, let's suppose I'm given a trinomial. Trinomial because there are because there are 1, 2, 3 terms, right? 8x squared minus 2x minus 50. Trinomial, 1, 2, 3 terms. Okay, the leading coefficient is 8. In this case, it was 1. So, if I try the table method, well, factors of negative 15, whose sum is equal to negative 2. Well, what am I going to get? I'm going to get 3 and negative 5, 5 and negative 3. That's it. So 3 minus 5 is negative 2. 5 minus 3 is positive 2. Okay, well, that's great. Now, if I try x plus 3 times x minus 5. All right, this is the one that matches up. I'm going to get x squared minus 2x minus 15. All right, well, that's great, but what's wrong here? I'm missing the 8. So the table method breaks down when I have this leading coefficient that's not equal to 1. So our other option is to list the exhaustive combinations. So I could have factors of 8. Okay, that's going to be x, 8x. Okay, so I'll continue in this pattern, x, 8x. Okay, so then I have 1 times 8. I have 2 times 4. Then I have 4 times 2. Then I have, again, 8x and 1x. 8x and 1x. Okay, so why did I duplicate it? Because now I have to account for these guys. So I'm going to have x plus 3, 2x plus 3, 8x plus 3. I'm going to have x minus 3, 2x minus 3, 4x minus 3, 8x minus 3. And I have to throw this 5 in there, huh? So I'm going to have 8x minus 5 plus 5 minus 5 plus 5 minus 5 plus 5 minus 5 plus 5. Okay, so I have 8 combinations here. Now, then I'd have to FOIL each one of these out and check which one matches up with that. That's a lot of work, and I'll show you it's not necessary. I mean, it certainly is, well, you'll get the answer eventually, but it's a lot more work than you have to do. So, yeah, why, well, first of all, let me tell you that even this, though it seems like a lot, this is a rather tame example. Sometimes they can get a lot more unwieldy than that. The more factors there are here, the more combinations you have, this list can get very long. So my goal here is to disincentivize you from using this method because it's not necessary. This is where we come to the illegal method. All right? So forget this. All right? Forget this. We are going to employ the illegal method. So, starting with 8x squared minus 2x minus 15, I am going to drop the 8 from the first term and multiply it by the last term. 8 times 15 is 120. Okay? So, now this is where it gets to our original question. Why is it the illegal method? Because in normal algebra, if I divide this by 8, I'd have to divide this term by 8 and divide this term by 8. Or if I multiply this term by 8, I'd have to multiply this term by 8 and multiply this term by 8. Notice I'm dividing by 8, doing nothing to the middle term, and multiplying by 8. Okay, that's a violation of our normal rules of algebra. That is why we call it the illegal method. So, from here though, all right, I have a leading coefficient of 1. So I could employ the table method. 120 has a lot of factors. Turns out, and you can check me on this, but we get x minus 12 times x plus 10. Okay? Now, because we got rid of the 8 up here, we have to bring it back down here. Dividing each term there. And now we simplify. 12 over 8 can be rewritten as 3 over 2. 10 over 8 can be rewritten as 5 over 4. We clear out the denominator by bringing these numbers up with the x. So I get 2x minus 3 times 4x plus 5. All right, so let's check our work with FOIL. First, outer, inner, last. So I'm going to get 2x times 4x is 8x squared. 2x plus 2x times 5 is 10x. Negative 3 times 4x is minus 12x. And negative 3 times 5 is minus 15. Combine like terms. 8x squared minus 2x minus 15. Lo and behold, this is what we started with. If you'll remember from the before I erased, this was in fact one of the combinations, but we have to sift down quite a ways before we found it. Again, that was a lot less work than going through each one of those. Now, okay, this is a specific example using numbers. Let's see if I can generalize it using letters as symbolic to show why illegal factoring works all the time. So, suppose I have ax plus b times cx plus d. All right? If I FOIL this out, ax times cx, acx squared plus ad plus bc times x plus bd. Okay, so this line corresponds to this line. Now, what I do, I got rid of the 8, so I'm going to get rid of the AC. I'm going to be left with x squared plus AD plus BC times x. And got rid of the AC here, brought it over here. I'm going to have AC, B, D. Now, because of the order of multiplication does not matter. That is, 1 times 2 is the same as 2 times 1. A times C times B times D is the same as A times D times B times C. Now, why did I rewrite it that way? Well, that's to make it very evident what the factors of ADBC are, whose sum is AD plus BC. We're going to have x plus AD times x plus BC. Boom. Okay? Factors of AD, BC, whose sum is AD plus BC. That's AD and BC. Okay, got rid of the AC up here. I have to bring it back down here. Divide by AC. Notice how the A's cancel there, the C's cancel there. So I'm left with x plus D over C, x plus B over A. Okay, let me clear out the denominator by bringing these up. I'm going to have CX plus D, AX plus B. Okay, it's exactly the same as this, other than the order of multiplication is reversed. And as we just discussed, that doesn't matter. 1 times 2 is the same as 2 times 1. So, we, quick recap. Reviewed FOIL, saw how to factor a trinomial whose leading coefficient is 1 by using the table method. Then we saw why it's cumbersome to factor a trinomial whose leading coefficient is not 1, because of all those combinations that I erased. Hence, I introduced the illegal method of factoring, using a specific example and then extending that to the general case, showing why it always works. Hope you enjoyed this video. If you did, please like it. Feel free to ask me any questions in the comments section below. Also, let's have a good discussion to bounce ideas off each other. What more could I have added to this lesson? Thanks for watching. Please subscribe to stay updated on future videos to come, and I'll see you next time.